Right, hi everyone. Welcome to a new video. In this particular video, I'll be discussing about web servers. So here we are trying to create a basic web server which handles some of the request types in HTTP. Let's get started. So I think we'll start with the main file. So I have included a header file called server.h, and we are running the server and we are returning once that's over. So that is the bare basic that is happening here. Now let's go into the next file where we go into the initial parts of the program. So this is the basic structure from which I'm gonna develop the program further. So I have included multiple header files. If you don't know what these files mean, the standard IO, stdio basically contains common functions that is needed for any program like print, scan, open, and you have standard libraries which contains things like exit and memory management. If you don't know what memory management is, don't worry about it. uh, we will be discussing that further. And string, uh, for string handling, so as I mentioned, we'll be handling HTTP requests, so it will contain some kind of strings, so we'll be handling that. And any web server, if you think about it, you are not the only one connecting to it. There are thousands of other people who are trying to connect to it at the same time. So we need something to create uh, multiple processes so that all the requests coming to the server can be handled. So we are using something that is built in C called fork. So this is the header file which includes that. And internet, as you know, has to contain IP addresses and some functionalities related to that. So the INET header contains internet operations and ways to handle IP addresses. And system wait is for waiting for the processes. And these are some of the other header files that I have defined personally. Now coming over here, like I have defining the port. So 1337 basically lead. This is the port that our server will be listening to. So if you don't know what a port is, your system contains thousands of ports. You have a range from 0 to 63,000 something. Um, and so you can use many of those ports. Some applications use some ports by default. um, and that's about the port. And I'm doing a backlog here because I'm keeping track of how many connections that I'm trying to accept at the same time. So if I get 10 connections, I once I process the 10 connections, it will be taking in the next one, so that my system won't be overwhelmed. That is kind of the idea here. So this is the start of the program. Like I'm starting a server with a, so this is pretty unique. You have something called server file descriptor, and you have a new socket, and we have a structure that we are defining here. Uh, so at a very fundamental level, what I'm trying to do is that I'm trying to create a file descriptor for each of the sockets, or for the sockets that I'm creating. Um, think of sockets as an endpoint for sending and receiving data over the network. So that is how everything works. So whenever you are connecting to the network, there's a socket being created. So the next part is to actually create a socket. So we haven't created a socket till now here. So now we are actually gonna specify the creation of a socket, that we are using AFINET sock stream and 0. Okay, we don't understand what this is. What does this mean? In order for a socket to be created, socket needs a few arguments in it. So the first thing is AFINet. What it means is that it specifies what type of IP addresses that we are giving. Are we giving IPv4 addresses? So IPv4 addresses look like 192.168.242.10. So that is an IPv4 address. So we are trying to accept a IPv4 address, and socket stream basically means there's something called TCP connection. Think of a lossless packet data transmission, that is called the TCP. We will be using TCP. We use sock stream. There is another called socket stream datagram. Then it will switch to UDP protocol. Like YouTube or any video serving platform uses that. But here, HTTP uses TCP communication, so we'll be defaulting to that. And zero is basically telling, hey, you will be using an IPv4 address and you will be using a TCP connection. Uh, so default to a communication which uses both of these. So communication that defaults to both of this is TCP communication. It's defaulting to a TCP communication here. And as you can see, we are putting an if condition here. So, and if you're checking if the if condition, if it is less than 0, so if it is going less, if it going to a negative value, it basically means there is some error there and it is failing. So it should actually be returning a positive value. Otherwise, it will basically won't create a socket. So now here we are actually specifying the address families that we are using, that we are using an AFINet, and we that is IPv4 addresses, and we are also saying that, hey, any incoming interfaces can connect to it, that anyone in the network with any interface can connect to our server. And this basically specifies the port, which port are we you know are they going to connect to. And the address input to HTTNS port basically means we will be listening to the port 1337, and this method in C actually converts this to a byte order. So don't worry much on it. It just says, hey, 1337 will be active for connection. So the next part of the program will be to bind and listen. What does it mean by binding? It means that you're binding to a particular IP address. So you're using the socket, right? So you're using the socket to bind to the IP address that is being connected. So you're binding to that IP address. That is basically what it means here. So, but you can see there are a lot of things that we are defining here. So as you know, we have the file descriptor that we have created here, and inside that we are defining a structure. So you might think, what will be here? It only contains the IP address and a few other things, but think of it mainly as you are having the IP address and IP address of the person who is connecting to you. So you're storing that information, and you are also saving the address of that particular person. So that the idea is to identify each unique person or each unique connection. That is what we are trying to do here. And again, if it is creating a value less than 0, it means it is failing. So otherwise, this will continue, it will bind to that particular IP address. And then we are moving into the next part, that is we need to listen. So that is um, um, so we have the yeah, okay. So listen basically listens on that particular IP, or see, we are given our IP address we are listening to our machine. Like, so the server will be actually staying here and listening for any incoming connections that is coming in. So that is what listen means. And we are also putting in a backlog, that is, so here the value will be 10. So here actually instead of this backlog we have already defined it here as 10. So it will listen on the file descriptor and for at most 10 connections at a time. And if there is any problem here, then it will exit. um, I want to repeat the bind part again because I think I told it kind of wrong. It's binding to our socket IP address. So we are creating socket and we are binding it to our IP address. That is what is happening here. So now we have successfully started a server on our application, on our system. I mean, I said it wrong. Now that we have successfully started the server on a particular port, I was mentioning at the start of the video that we want to be accepting multiple or thousands of connections. That is what web servers do. Like they will be handling hundreds of connections or thousands of connections at the same time. So we want something to create multiple processes for each connection, because you cannot, say you are connecting and I'm connecting at the same. We don't want them to be interacting with each other. They want to be separate things so that nothing else happens. So each process should be unique. So in for doing that, I'm actually creating an infinite loop here. Then I'm creating again a new socket which accepts uh, you know accept the connection. This is for creating. So the idea here is, um, when a second person or third person connects to the system, it creates a new process where all of the connection starts again. So that is why we are giving a file descriptor, server file descriptor here, and we are giving the address, the IP address details, and what is the address length. So what all are the details there, or what is the length of the structure there, and we are creating a new socket. And if it is less than zero, like we're going to throw a error because it should not be. um, then this is the funny part, that is we are creating a fork. So fork basically creates a new process ID and a new child process. um, so if you don't know what a child and a parent process means, in this scenario the parent process will be the one that will be the server listening out for communication, and the child process will be the scenario where, say, you're connecting to the application and you will become a child process. So that is how the server is going to work. And handle request is a method that is there in our request handler file. So I'll be explaining that in further. But before that, uh, see, once you have connected to the server, there is no need for that process to be looking for other connections. So we want to close that. So that is why we are giving the close here. And then whatever information is coming through you, we will be handling it with this handle request. And once all of that is done, we will close the socket altogether because that child's work is done. And finally, we are exiting the child process. That is happening here. Then so then if there is anything else that is going to happen, we are going to throw an error. And if everything else is done, we'll close it. This is a pretty cool thing. Think of it like, say hundreds of people connected and everything is happening, and you want to clean everything up before the parent exits. So this basically, the wait PID checks if there are any child process left, and it won't let them hang. So this basically means they won't, the uh, the application or the program won't let it hang. The parent process won't let it hang. So it will let it continue and complete its thing. And once it's completed, it will terminate it. So that is kind of what it does. And finally, we will close the initial file descriptor that is there. So that is kind of the flow here. So we discussed a lot of things in this particular server file itself. If you didn't understand anything, feel free to reach out.